Good morning, everyone. How are you doing? Everybody good? Nice. Yeah, I'm really excited to be here, not only because it's Italy, one of my favorite countries where I truly want to retire one day, but also because I'm actually excited to be talking about the topic that I'm talking about. And it seems weird. Why would anybody talk about something they're not excited about? But for many years, I kind of lost it a little bit because, I'm 37 years old. I started doing web development professionally when I was 18. So if you do the math, I've been a developer longer than I was alive before I was a developer. And at some point, when you do the same thing for a few times over and over and over, you start to kind of see the brickwork, behind, the shiny facade. And maybe you notice that we're just repeating the exact same thing over and over again. We're just building the same things again. We make it more complicated. Then when it gets too complicated, we make it simpler. But we just keep sort of like, repeating this eternal loop, over and over again. But what's happened in the last year and a half in my life and in all of our lives as developers is that we now have access to these sort of very novel ways of interacting with the computer using modern AI models. And I've been fortunate enough to be able to work on them. And I want to share something about what we've been working on. And hopefully you can take this home. And when it's time for you to experiment with these technologies or maybe use them at work, you'll get a little bit of a kickstart out of it. And you don't have to learn all of these things the hard way like we did. Sound good? I think what drew me to being a web developer or just to the web as a user to begin with was this idea that the web can advance connection between people. And obviously that's true. It's literally what it does. It connects people. But it kind of felt for a long time that technology was this thing that enabled us to be more human. But now recently in the last few years, it felt like it's making us less human. We're addicted to our devices. We use social media that was meant to make us happy, but now it makes us sad. We stare at these rectangles, on our screen instead of talking to other people. And that's not ideal. And I kind of got really depressed about this a couple years ago, and I almost stopped being a programmer just because of this. And in fact, I never wanted to be a programmer at all. I wanted to be a writer. I went to school for literature, not for computer science. And it's because I've always been fascinated by stories and language and the way that humans communicate with each other. Stories, they power every form of entertainment. Every movie, every play, every comic book, it's a story. But more than that, stories is how we connect to each other. Stories is what makes humans human. What enables us to learn as groups. It enables us to communicate, to be more than just our individual selves, right? So I wonder, why haven't we as technologists been able to sort of build tools that help writers write, storytellers tell stories, right? Every other form of art seems to have some sort of software that helps, the actual, understands the actual medium. Visual artists have Photoshop, photographers have Lightroom. There's AutoCAD, there's modeling software. But for storytelling, beyond Microsoft Word and some storyboarding stuff, there really hasn't been that much. And writing a good story well is really still like a hard thing to do, and it always will be. But it's a shame because it's the most democratic form of expressing yourself, right? Not everybody has access to an expensive camera. Not everybody has the time and the privilege to spend, years learning an instrument or learning, to sculpt or to draw. But we all intuitively know how to tell stories. And the reason we haven't built these tools is before now, language has been too complicated for machines. Machines have been really good at things that we humans, squishy meat brains, are really bad at, like math and memory. But things like language, things like communicating, expressing ourselves, is something that has been uniquely human. But recently, with the advance of these new types of models, we can now interact with machines as if interacting with another human. And my hope is that at the end of this, AI won't take our jobs, it won't, destroy humanity, but instead it helps us build technology that is more human and more connected and more accessible than ever before. And so today, I'll show you how we've built something And when you look at what we've built, I hope that you can sort of project this to the things that you're working on, things that you're passionate about, and think, how can you build something, for yourself or for others? So my name is Jani Eväkallio. I'm an engineer. I'm from Finland. So when I say I'm excited to be here, I really am. It's just my face doesn't always show it, and my tone of voice, is a little flat. But Finnish people, it's a common myth that we don't have emotions. We do. It's just that our face doesn't participate in the transaction, so it's a little hard to tell sometimes. Alongside myself, I want to mention two people: Ryan, who runs product and design at Verb, and Jeff Elmore, who runs machine learning at Verb, and who also helped me design all these beautiful graphics using Midjourney for this talk. So. Oh, by the way, you're about to also find out I'm somewhat of a magic move aficionado. So if you have motion sickness, close your eyes when I press this button. So let's take a look. This is what Verb looks like. It's a fully functioning web-based writing app. It understands things like your characters, your story structure. Is it playing? Yes, it is. It can give you feedback on your writing. It can also help you get through things like writer's block, or help you describe the thing that you're looking to describe. It can help you rewrite, text that you have yourself done, and it can do so much more that we don't have time to go to. But I'm not here to sell this to you because you probably aren't fiction writers, you're software engineers. So let's focus on the things that matter to us. This story, like all good stories, will be story in 3 acts. In the third one, in the second one, there will be no gun, and in the third one, it will not be fired. So do not worry. First, really quick intro about what we mean by AI. Lizzie did a great job yesterday explaining this to us, so we don't need to go into too much detail. The meaty part is part 2, where we talk about UI. How do we actually build user interfaces that are collaborative and helpful to our users? And part 3, how do we actually build these things technically using JavaScript? This is jsday after all. So, start with AI. Not a big fan of term AI. Kind of overloaded, kind of full of hype. There's the saying that if you're selling something, you call it AI, and when you're hiring, you call it machine learning, and when you're doing it, it's just linear algebra. It's fundamentally, there's one of these terms that is, so overloaded by popular culture, science fiction, marketing. So let's not call it AI. Let's call it large language models, because that's what we're really talking about. And many of you will be familiar with variants of this. I think GPT-3 and ChatGPT are at least the most well-known ones. But there's also tons of other ones. There's Bloom, for example, which is an open source model that's trained using the exact same technology. And every big tech company now, Google, Facebook, Microsoft, have their own models. And the reason, these tend to be mainly from larger companies right now, because it's really expensive to right now to train these models. The computing resource and the know-how is still quite expensive. But I do believe that these are going to be more democratized in the very, very near future. So, I think in the next year or so, you will be able to run your own large language model on your M2 MacBook. You already can run Facebook's Llama, but it's very slow. So, if we take the example of GPT, I'm not going to give you the dictionary definition, but just to give you an idea. So generative, these things are meant to create things. Not all AI models are. Later we can have a talk about detecting breast cancer in scans. That's a great use for a type of AI. But we're talking generative. The technology that powers this is called transformers. And this is essentially an evolution of years and years of language modeling research, where moving from this kind of bag of words model, adding this sort of like attention mechanism into the algorithm, we're now able to both understand and produce long pieces of text, which is very useful for actually creating cogent output. But the big thing here is nothing to do with the actual machine learning part. It's the actual compute and training data part. Historically, it's been really, really difficult to build machine learning applications because the computing power needed, the data needed, but also, most importantly, the specialism to translate a human process into a computing process has been very, very difficult. What these models have now done is, or what people have done with these models, is they've trained them with essentially all of human knowledge. All of the available internet, a lot of copyrighted material that should not be here, which I believe, which is why ChatGPT is currently not available in this country. And essentially, what these models now make possible is to build things in seconds that would have taken hundreds of hours of compute, hundreds of hours of programming time, and that's pretty incredible. And the way that we use this is really by asking it to complete things. All of these sort of large language models do is they figure out the next word and a next word and a next word and a next word in a sequence. It's essentially a fancy autocomplete. But just to understand everything that's going on here, this is the OpenAI GPT playground. The black text is our prompt. The green text is the response. So if this was an API call, the black text would be what we would send in, and the green text is what would come out. And everybody, of course, knows ChatGPT. Not going to spend a lot of time on it. But here we ask it, for example, more information about the song that it just completed for me in the playground. And what's interesting about this, that even though this thing is just a fancy autocomplete that can predict the next word in a sequence, what it can also do is take input, requests, questions, and answer them. I'm saying the obvious, everybody knows this. But what's interesting about this is that it's a curious feature of human language that a question is often followed by an answer. But furthermore, these models have been sort of like trained with human feedback reinforcement learning to be more helpful to specific type of questions. So that means that even though they are a fancy autocomplete, there are specific tips and tricks and things that you need to be able to sort of like understand conceptually in order to get the most out of them. And collectively, we call this prompt engineering. And if I said I don't like the term AI, I fucking hate this term. Not a huge fan. We finally have a technology that allows us to talk to a computer like a human, and then some asshole goes like, hey, let's make it sound really complicated and intimidating. Like, there is no reason to disintermediate our access to the computer. It's not engineering. You're literally talking to a computer. The fact that you type in a keyboard is just an accident. If you have Siri, you can press this button right here and say, Siri, give me this answer. But the engineering part here is that there are some sort of useful sort of concepts that are good to understand to get most out of these things. What this sort of instruct tuning, that kind of reinforcement learning that's applied to these models, enables us to do is to ask questions without providing examples. Historically, this is not how machine learning worked. Usually you provide millions of examples in order to get something out. Here we can just ask something. What's also interesting is that this sort of instruct tuning works for asking questions. We've already gone through this. But if we were to build an app, let's put ourselves into a mind of building an app on top of this API. What is this haiku about? We give this haiku. We get this paragraph answer that is longer than the haiku. It's boring. It contains a whole bunch of shit that we probably don't want to show the user, right? How do we actually work with this system in a way that makes it usable in an app context? The other way that we interact with these models in a prompting strategy is something called few-shot learning, which is essentially just like a tiny, tiny little version of how you would traditionally train or fine-tune a model. Instead of providing a million examples, you provide just a couple, and you combine all of the information that's pre-trained into the model with the sort of the pattern matching capability of saying, this is the format that we want things in. So here, we ask for a haiku, but what's interesting about this is that here we have a pair of A's and B's, right? Like we give it A, B, A, B, A, B. Here's an A, give me a B. That works the other way around as well. So A, B, A, B, A, B, but now actually here's a B, give me an A. So you can use this as a classifier, as a question answering machine, as a data processor, as a literally anything that can, can be answered in a format, you can get it in a special format by using sort of this few-shot learning ability. And once you figure out what your actual task is, you can then basically get 1,000 of these examples, send those over to, for example, OpenAI's fine-tuning endpoint, and then you have a specific endpoint that is targeted towards that one job. Extremely powerful. But let's say, and now let's start to get a little bit more into the UI part. Let's say we wanted to build, for example, this screen. This is a screen from Verb's feature. It's a little fun toy feature that we have called Brainstorm. It's not really meant for serious writers. It's mainly for you don't know what you want to write. You just want to get a little seed of a story. So you give one word, and then we give you a sort of concept of a story with, we have a character, we have a story summary, we even have scene descriptions, and what doesn't fit in the screenshot, you even have a first sentence of the story that you can then continue writing from. How do we get this kind of structured data out of a model? Well, this is the fun thing. You can just ask it to give it as a JSON. So here, the exact same sort of A/B mechanism under there, the grayed out, you see some examples. You know, you can essentially just ask the model to provide the output as a JSON. But my favorite one, and this is more of a fun hack than anything, is to ask things as YAML. And you might ask, why on earth would you want data as YAML? That's a stupid data interchange format. And it's because YAML is different from JSON in the sense that JSON requires, you know, an end curly brace in order for it to be parsed. It's also very finicky about having the commas and the quotes and escaping and all of those things just right. YAML will eat anything. But most importantly, you can stream YAML because YAML document is valid, you know, character by character. It doesn't require end tags. So you can actually build those incredibly fast streaming UIs by just asking data in YAML format, and then on every token that you get it from the API, you'll just parse the document as a YAML, and then you bind it into a UI. Anyway, fun stuff. But now let's start moving towards like the beef of this. So if large language models are just versatile completing machines, like what attributes do they actually have? Are they creative? Are they factual? Are they accurate? Are they reliable? Are they able to reason? What can you use these things for? And the answer for all of these things is kinda, but not really. Are they creative? Do they possess any kind of creativity that human does? Absolutely not. But creativity is born out of the interaction between you and the machine. Are they factual? No. Sometimes they give you the wrong answers, but they know a lot more than you do. So, you know, it's again like this collaborative partnership between you and the machine, using this tool for what it's good for, understanding its boundaries, understanding where you can be relied on and where it cannot. Same thing for accuracy or reliability. And this reasoning thing is interesting, which we might leave for the end if we have time to talk about it. But essentially, the opportunity here isn't to have just a better Google that can get you facts. Like, computers used to be good at, like I said, in two things, maths and memory, right? These things are terrible at maths and memory, but they're good at the things that computers historically were really bad at, reasoning, creativity, sort of natural fluid use of language. So like figuring out what does it actually mean to collaborate with an AI? Like what is collaborate even the word? Are we using it? Are we working together on something? Is it a partnership? Is it a, you know, like is it a tool? I think these are the kind of things that you know, we've been exploring, and I think you know, we'll get to now in part 2. So we've identified some modes of collaboration between human and AI. The one that we've all seen is chat. We don't need to go into it. But what's interesting about a chat is that a conversation between two humans is collaboration. But normally those two humans already have some shared context of what they're talking about. Talking to, you know, a ChatGPT, something with a limited memory, is like going to a meeting, but the other person doesn't know what the meeting is about, and you need to tell them everything. It can be collaborative. They can have some information, you know, in this meeting, you know, they can help you achieve your goals. But fundamentally, it's a little limiting because every time you start over, you need to tell them everything about the past. And especially if you have more data or more context or more documents you need to feed in, it can be quite difficult to do that. So what we think is going to be sort of, I don't want to use the word future, but like what is really powerful and already immediately available today is this idea of bringing these AI features in context into the application that you're building. So in the case of writing here, for example, what am I asking here? I'm asking to describe her response. Who is her? Who is she? What is she responding to? What is the context here? We don't need to tell the machine. The machine already knows, because this thing happens within the context of your own work. We've taken a very simple, similar concept of like auto-completing a sentence. We even made it green, just like you know, the OpenAI Playground does. But fundamentally, what we are able to provide is the ability for you to stay in flow while you're working, not need to explain something to the machine. And this is how humans collaborate, right? Like you're working on a document together. You go like, what would she say now? Well, let's find out. Instead of going, oh, ChatGPT, please give me this you know, answer, given that Caroline is Andreas' wife and Andreas just has come out of a coma. Like, that is not going to be a very collaborative approach. So first, bringing things in context, I think, is incredibly powerful. The other thing that we can do when we bring things in context is that we can not only add new things additively, but we can also do tasks on top of our existing data. All of our data is available to the machine when we integrate it this way. So we are able to, for example, here ask rewrite a piece of text. If you're in a business domain, you could, for example, say, oh, summarize all of these, invoices or pay all these invoices. Like you could literally imagine any case where given access to the sufficient data and the task of the user at hand, the AI soon will be able to figure out. Somebody just showed me 10 minutes left, but I think this is a 40-minute slot, isn't it? Yeah, okay, so 20 minutes left, thanks. Just, keeping you honest. And also I panicked a little bit, so. I don't know, was there anything more I wanted to say about the tasks? I don't think so, yeah, that was the basic idea. But then, all of the examples that we've seen so far have been, us asking the machine to do something. And that is certainly a form of collaboration, but it's more of having an intern, Please go get me a cup of coffee, please do this thing. But a human collaboration typically tends to be two-way, right? A team of people can collaborate on something together. So what would it be like for, these AIs to be assistive, to be agentive? Of course, they don't have their own agency, they don't have their own goals, but they can act as agents on your behalf, make you suggestions, do tasks for you even before you ask for them, then verify whether this was the right thing to do. I think that's pretty damn powerful. And so if you think in your context of the apps that you're building, you can probably think of examples in which common user tasks could be done this way and then make the whole application so much more useful and powerful. But whatever app that you're building, whatever context or domain that you're working in, I think there are going to be some shared UX principles that will be helpful, and these are the ones that we've identified at Verb. I would guess that most of these, if not all of them, will apply to pretty much every case where a human and a machine are collaborating on a shared surface of data. We'll go through them one by one. First of them is really just idea of bringing functionality into flow. We at Verb, we use this sort of like a Notion style / menu, but it could really be anything. It's this idea of, if a tool is to be useful, it needs you to stay, enable you to stay within the workflow that you are in and not take you out of it. So this is why using like a secondary tool or a secondary box that you need to go paste some text into and then paste it back is actually really destructive because it takes you from the workflow that you're currently in. Things also, generally need to be fast. What we found is that even 2-second wait, 3-second wait for something really takes you out of like the feeling of you collaborating with something, and looking at a loading spinner makes you feel like you're just basically waiting for a dumb machine. And these models currently aren't very fast, and it's very doubtful that they will be instant in the same way as a database request is instant anytime soon. So for that, whatever model you use, you're most likely going to be able to use the streaming capability of just taking token by token by token by token instead of waiting for the whole response. So that's what we do here. And we also have this really fun loading spinner that we do, where we just basically run a really, really quick local model to kind of like get a bag of words that are related to your query, and then we show them as if it was thinking about the thing, which of course it's not. It's nothing to do with that. But just like these tricks of like making this thing feel fast have been hugely impactful, the kind of user success and user happiness around these things. We've already talked about context awareness, but the idea that the less that you need to tell the machine, the better. The idea of intelligence, in case of artificial intelligence, really breaks down when the thing feels dumb. So making it feel intelligent, making it feel like a partner, I think is supremely useful, powerful thing. Making things rerunnable, I think, is also something that we found really useful, because sometimes you just don't first get what you want, and just having this kind of like quick button that you can mash for like no, not that, will help the user, but will also save you on token costs because you don't actually need to complete running the whole rest of the operation. You can just cancel out the rest if it's not going the right direction. Similarly, making things tweakable, because sometimes it gets things almost right, but then there's something a little bit off about it. And again, like having to go, in case of creative writing, actually, it could be reasonable that you would read the whole thing, make your own manual edits, and this is actually how most writers use this feature. They don't just have AI generate stories for them. It's more of a partner where you then go and like edit it. But in most sort of business use cases, having the ability to sort of go like, yes, but, I think is super powerful. And here we start to actually get into something that we'll get to in a little bit later, but I'll point it out now, is this idea that when you first, when you design software, user interface the classical way, you think of everything as a button or a knob. Like, we need a button to make something less romantic, but then we also need a button to make it more romantic. Do we need a romantic slider? Like, what's the user interface, for this thing? What kind of combinatorial madness will we get to, when everything is possible? And the thing is, this is the sort of like the build out the intuition for designing interfaces that operate natural language input and output. It's not just that we're using, generating text or outputs or artifacts or actions, but the format by which we communicate with this machine is both iterative, it's question and response, but it's also always freeform, which is super powerful because it enables sort of your users to decide, sort of like follow the desire lines of the application design, and like if something isn't made possible, they can still do it. And then if you track analytics and you do qualitative surveys and you use like sort of mechanisms of tracking the kind of things that your users ask for, you actually discover the things that they really mainly want to do, and then you can build those out into more specific features, as we've done with shorten and lengthen, which were very common things that people used to do, and now they're buttons. So very powerful to kind of like track that sort of user exploration. Things also generally tend to be should be reviewable. So if you are about to change something that the human themselves wrote, you shouldn't just replace it. People get a real sort of like heart attack reaction, like somebody shows you a 10-minute warning in the middle of a 40-minute talk. And you don't want that. So like every time you sort of like change something, you should ask the person, is this what you really wanted? And then even in the cases where you did ask, everything should always be undoable, because sometimes you make a mistake, you change your mind, and like having data loss, having the ability to sort of like go back is like increases psychological safety and the sense of collaborativeness between the human and the machine. And this is maybe obvious. Maybe all software should always be undoable. Just Command Z or Control Z. But here I think it becomes exceedingly important, and we'll talk a little bit about why this is maybe a little bit more complicated than it would be in a traditional application where you can just rely on the browser's own sort of undo for a text input or something. And then fundamentally, making everything non-destructive. So like never break anything that the user themselves wrote. That's a really easy way to to piss off a user and make them never trust the machine again. So to foster that sense of collaborativeness, be very careful not to overwrite something the user themselves did. So if user is editing a text field, if you have an agentive AI that then goes and replaces it, that makes you mad. Would make me mad, and has made many of our users mad. So this is a good principle to follow. But so natural language, it's very interesting. We've seen, hopefully I've demonstrated how flexible and powerful and intuitive it can be. Are we around on the same page here? Do we feel like this is a good way of maybe using computers? Yeah? Okay. But the problem with natural language, from purely like even like a mathematical grammar kind of sense, is that it's not regular. You don't always know exactly what you're going to get. Languages also exists only in a context. Like a sentence only makes sense if you know what the sentence preceding and sentence after are. And it's not parsable in the same way as structured data. We show the example of JSON or YAML, but you've also seen parts of UI where we're essentially sort of editing just a big blob of text, and it is not necessarily that clear, sort of how to sort of like bind that in the UI. And so here we get to the third part of the talk. We're right on time. So I started this talk by saying that it feels like we're just doing the same thing over again. We're rearranging rectangles in complicated ways. But that's actually not a bad thing necessarily. Rectangles are very powerful for user sort of cognition of the way the UI is constructed. But they're also very useful for programmers, right? Because you can generally have a structured piece of data, and then you can map a datum into a field, and that field is a rectangle. A div is a rectangle, an input is a rectangle you can type into, an image is a rectangle with pixels in it, video is a rectangle with moving pixels in it. You know, like everything kind of like binds very clearly into these neat boxes. And yeah, sometimes you do a bit more complicated things like that. You might actually have one field that is first name, last name instead of separate first name, last name fields. But like fundamentally, you're doing fairly basic data transformation in order to sort of like edit your UI. And similarly for lists, you know, like you have a list of data, and then, you know, you basically get a list of rectangles out of it. Sometimes the list is a grid, sometimes it's horizontal, sometimes it's vertical, but like it's still fundamentally a list. Thank you. We have 10 minutes left. And so this is how basically all of our modern web development tools have been built. For a very good reason, you know, very applicable, like a good tool for the job, right? Like this is a piece of React JSX code, but you know, whether you use Svelte or Vue or any other framework, it fundamentally works pretty much the same way. You iterate over something, you render a DOM element for something, you bind some data into it. And then what the frameworks do, whether they use virtual DOM or signals or whatever, is that you have a list of things, then you edit the data, and then it inserts the thing in the right place in the list. Very beautiful, very simple, declarative, and we've kind of started to take this for granted, I think. You know, this is a powerful mechanism, which we didn't used to be able to do. We used to manipulate DOM like apes, but now, you know, we've kind of like gotten used to this mechanism. The problem in natural language is that it's kind of weirdly squishy, and we didn't really realize this when we first started to build this software. And this is a little harder to explain, but what you will probably find is, unless you know, like you sort of confine your AI to this idea of, you know, you have your structured data, maybe you have like a form in your business software, and you ask the AI to fill that form, then this problem doesn't actually touch you. This is fine. You know, you're still dealing with structured data. But when the human and the machine are editing a shared surface, and that, you know, surface is not necessarily bound to, it could be, for example, a text area or a rich text editor, like in our case, you suddenly get into this weird thing where like you end up doing this jQuery, you know, style manipulation. Take this text, insert it here in this location, but then it gets really complicated because text isn't really content addressable, right? Like you can't just say, oh, at this position in this text, because things can come out of order. You know, like you get into really complicated scenarios where the UI feels glitchy, or you accidentally overwrite some data. Then you add like offline scenarios to this, where maybe you know, user is writing while the AI is thinking in the background. Somebody comes online. What happens then? It gets really tricky. And so what we started to wonder is like, is there a framework for efficiently working with, you know, natural language interfaces, specifically the output interfaces where, you know, two entities collaborate on the same data? So if we look at, you know, our app, very sort of structurally basic. You know, it's a React TypeScript app. We use a rich text editor called TipTap. Underneath it uses a library called ProseMirror, which is both the best and the worst rich text editor at the same time. If you build something like this, you should probably use it, and you're going to hate it. But it's the best game in town. Now, our app talks to a BFF. Yesterday, Tejas talked a lot about this pattern that is happening, where, you know, every front end brings its own backend for front end, or best friend for front end. And so the question is like, what do we use? So what do we use? Next? I can't even, what, PHP? I like, what is our BFF, you know, strategy here? And the thing is, yeah, well, okay, let's actually explore this a little bit more. Our BFF eventually writes all of the text that you write into a database. We have these magical bots that go and read the text. They run sort of like various machine learning processes, both API bound and our own machine learning things, to extract information about things like your characters, the story, you know, yada yada yada, and they put it in a database. This is a searchable database, so it could be Elasticsearch, could be Verona, was it yesterday presented? Orama, that's right. Could be anything like that. You know, in our case, we use something called Pinecone, but it doesn't really matter as long as it can be embedding based searches, where you can bring your own embeddings. So using, you know, a sentence transformer model instead of like a built-in sort of stemming model, you can use this. And then we have these bots that basically feed from that database, and they're able to do things like provide suggestions, but also generate text for you, you know, sort of interactively and independently operate on the shared surface of your document. So question is, what is this BFF? Like, what is this magic box that we have here? What we found is that we actually don't want an API or a program. What we actually want is a data structure. We want specifically a data structure that is able to resolve conflicts over time and interactively in real time. So there's this category of algorithms called CRDTs, or conflict-free replicated data types. Can I have a show of hand who here knows about CRDTs in general? Jesus fucking Christ. Okay. All right, we're gonna need another 10 minutes, sorry. Okay, so CRDTs are these data structures that allow multiple clients to update the same document and guarantee that the resulting document always ends up in a consistent state. Not only from a field by field level, but even within a string. And what's really cool about these is that you can do it in real time or asynchronously, and no matter how many concurrent editors connected to it, the algorithm itself guarantees that things are always inserted in the time that they were inserted in the logical clock time of what the document was at the time it was being edited by that client. Doesn't always make sense in the sense of like natural language. If two people are editing the same sentence and they don't read what each other are writing, then of course, might be more of a, sort of ad-libs, mad-libs kind of scenario. But this is what these algorithms do. And we use an implementation of this called YJS. YJS is a JavaScript, TypeScript implementation with optional Rust backend if you're into that kind of stuff. That is able to essentially provide sort of some of these qualities, characteristics out of the box. So, it provides the automatic syncing. So, essentially any clients editing the same document will eventually become consistent with each other. You can do offline support, because as a writer, you actually do want to sometimes go offline so you don't get, Twitter notifications and other things disturbing you. But it can also operate in a peer-to-peer model where you necessarily don't even need a backend if you don't want to. Now we do want a backend because we want the AI to be able to read it. So in that sense, it is a peer in the network. But what we do is we host one of these YJS documents in Cloudflare Workers using PartyKit, which actually Sunil will be talking about next. And what this gives us is a really interesting thing where like our backend is almost code-free. Like obviously, eventually we have some, database insertion code that figures out what changed and like put it in there. But in terms of like the collaborative real-time backend, that powers, essentially all of the user interface is almost code-free. It's just a YJS shared document with some information about what kind of data is expected to be in there. And to give you a sense of code, I'm not going to go deep into this, but you create one of these documents. You can have maps, arrays, just text, string fields. You can edit them, insert them, and if somebody elsewhere edits it and eventually syncs it, those things are going to be in a consistent state. A terrible API, but thankfully there are libraries for that. So you can use, for example, something called synced store, which provides a very sort of MobX-like interface for it, where you just create a store with a sort of optional TypeScript types if you're into that kind of thing, and then you can just say, oh, to-dos push with your data, and then eventually that thing gets synchronized into things. And this thing has actually support for text editors out of the box. So our text editor, which is this prose mirror monstrosity, is just able to synchronize into this document without us having to write any kind of code to do it. So super powerful. So putting this YJS thing here, essentially gets us to this place where Verb AI has just joined the chat. It can actively, write into the document while I'm in the document. We don't actually, show the, the user flag like that. We're not actually sure that users want to see the AI just as another user, but technically we could do this. So it could be a purely sort of like shared collaborative experience. But when we look at this picture and we look at what this is able to do, another thing that immediately jumps out of this is that there's no reason that it just needs to be those bots and those humans. It can also be, multiple humans editing the same document. We have accidentally created a real-time multiplayer application that enables collaboration not only between a human and an AI, but also any amount of humans with or without an AI. And what's really powerful and interesting about this is when we talk about making software that is more human, not less human, when we talk about software that enables sort of people to get their work done, AI is incredibly powerful technology that will only get more powerful, as time goes on. But fundamentally, it will not replace, human cognition, human reasoning, human creativity. And so I do believe that all software, whether with or without AI, should probably sort of think about like creating a sort of a collaborative interface. And adding AI to that just happens to be particularly easy because you already have the infrastructure set up for it. So I have 1 minute left. What's interesting about this idea of humans and machine collaborating is that like the machine's identity, I think, is questionable. The machine's agency is questionable. But what the machine is really, it is a collection of human knowledge just mediated by this novel interface that we can use it with. So in a way, like, it's interesting to think about this idea of you collaborating with the machine. It's just you collaborating with the collective wisdom of human knowledge with some annoying errors inserted in between just for a fun challenge. Yeah, I think there's interesting sort of ethical conversation to be had about what does it mean to download all of human knowledge into a machine. And the Italian data privacy watchdog has taken a very sort of grim view on this particular thing. And I think that's a conversation that we need to have. But I think it's also, as developers, we have the option of deciding, how do we treat, like, I think at this point, it's not feasible to just put your head in the sand and go, I believe these things are wholly unethical to the point where they should not be used. But I think we can choose how do we use them. So in Verb, for example, one of the most requested features that we have is, let me put in the name of an author so I can write in their style. We don't put that in that feature because we don't believe that that is doing right by the author whose information, whose data, whose writing has been, without their permission, their consent, any credit or any compensation fed into those machines. So I don't know. I think there's choices. And I think, just generally speaking, we are at this juncture where we talk a lot about, is AI going to destroy humanity? Is it going to help humanity? OpenAI's mission to create a friendly AI is so fucking stupid. I don't understand how the entire human sort of collective sort of sense of irony just hasn't gone blah blah and just booted them out. But anyways, that's neither here nor there. I'm not generally a techno-optimist. I think we've seen a lot of, we saw a great presentation about Web3 yesterday, just now. Incredible power of decentralized technology that can be used for good, but mainly is used for grifting and scamming and trying to make rich people richer. So, I'm generally not a huge sort of believer that things will turn out, but I think we do have a role to play here as engineers. I think we can sort of choose the things that we build, and hopefully we can choose wisely. Anyway, that's it. Thank you very much.
Thank you so much. We're running a little bit over time, but I do have one question.
Sure.
So how would copyright work with the resulting novel that you would write?
That's really interesting. So some publications, for example, the journal Nature, the science journal, has taken a grim view where they don't credit GPT as a author, but you can choose not to also credit it as the person who uses this as a tool. So it's very much given to the writer themselves to figure out where the ethical boundaries and lines go. I believe we'll see some legislation around this. We don't really know what it is, but right now, what Verb, for example, does is that it keeps track of every single word that was generated by AI versus the words that you wrote yourself. So when it comes time for you to publish, then you have actually transparency between you and your editor and your publisher to figure out whether this is legally within their, I guess, the comfort zone. But yeah, no, I don't necessarily have a sort of personal view on it, but I do believe that we do need to rethink copyright in this case. We do need to, compensate credit and sort of just get consent from people whose work is fed into these things. So hopefully we'll actually see smaller models that are less, robber barony than the ones that we have currently. But eventually, I think we need to get into a place where these things can be used both as copyrightable publication and as kind of source of original work. Otherwise, they're useless, and I think that would be sad.
Yeah, I agree.
All right.
Thank you.
Thank you.
Jani.